Hi, in this video we will discuss Rutherford's gold foil experiment and how its results led to the replacement of Thomson's plum pudding model of the atom, and we will finish up the video by looking at Bohr's model of the atom. In 1904, the accepted structure of the atom was based on J.J Thomson's plum pudding model, which, as you may recall, consisted of a sphere of positive charge in which were embedded the negatively charged electrons. However, a few years later, in 1911, one of Thomson's ex-students, Ernest Rutherford, along with two of his colleagues, Geiger and Ernest Marsden, decided to investigate the plum pudding model of the atom in a little bit more detail. Their idea was to fire fast-moving alpha particles at a thin sheet of gold foil. Now, alpha particles are dense, fast-moving particles which consist of 2 protons and 2 neutrons. In fact, alpha particles have the same makeup as you would find in the nucleus of a helium atom. Now, the alpha particles, which can be produced by the radioactive decay of certain heavy metals such as polonium and radium, are fast-moving dense particles with a 2+ charge. You can actually think of them as very small bullets, and Rutherford would have expected most of them to blast their way through the cloud of positive charge in Thomson's plum pudding model of the atom, with perhaps a few being slightly deflected. A simple outline of the experiment carried out by Geiger, Marsden and Rutherford is shown. Here, a radioactive element such as radium is placed in a lead box with a hole at one end, which will allow a stream of fast-moving alpha particles to be emitted from the box. Next, a thin sheet of gold foil was placed at the centre of a fluorescent screen which was coated with zinc sulfide. Now, this material will flash when struck by an alpha particle. Now, during the experiment, most of the alpha particles simply passed straight through the gold foil as expected. However, some were deflected through small angles, some were even deflected through larger angles, and about 1 in 10,000 actually bounced straight back, as if it had hit something solid inside the atom. This is definitely not what Rutherford was expecting. Now, if the plum pudding model of the atom was correct, then Rutherford would have expected most of the alpha particles to pass straight through the gold foil with only a few being deflected, simply because the cloud or sphere of positive charge in the plum pudding model would not have been sufficient to stop the small dense alpha particles. The most astonishing result for Rutherford was that around 1 in 10,000 of the alpha particles bounced straight back from the gold foil. Rutherford said at the time that it was as if someone had fired a 15-inch artillery shell at a piece of tissue paper and it had rebounded and hit you. From this observation, Rutherford realised that there must be something very small and very dense in the centre of atoms, since only a small number of the alpha particles actually bounce back. Now, Rutherford was able to calculate the size of this nucleus inside the atom, and he found it had a diameter of about 10 to the minus 15 metres. That is, the nucleus is about 10,000 times smaller than the size of a typical atom. Now, since most of the alpha particles pass straight through the gold foil, Rutherford realised that most of the atom was in fact simply empty space. Since the nucleus is very small, the chances of an alpha particle hitting it or even coming close to it are quite small. However, the fact that some of the alpha particles were deflected told Rutherford that they had come close to a region of dense positive charge. The closer the alpha particles come to the area of positive charge, that is the nucleus, the greater the angle through which they were deflected. Based on these results, Rutherford suggested a new model for the atom to replace the plum pudding model. In this new model of the atom, there was a small central nucleus where the positive charge was concentrated, and the electrons were orbiting around this nucleus, much like the planets orbit surrounding the Sun in our solar system. Although Rutherford's nuclear model of the atom was a more accurate representation of the actual internal structure of an atom than J.J Thomson's plum pudding model, it had one major drawback or problem. Since the nucleus contains positively charged protons, what was there to stop the negatively charged electrons which were orbiting it from simply crashing into it? Now, the answer to this problem was provided by the Danish physicist Niels Bohr, who suggested that the electrons were only allowed to orbit the nucleus in certain allowed energy levels or shells. Hi, thanks for watching. If you found this video helpful or would simply like more information, then why not visit the website that accompanies these videos? The links are in the description below.